Okay, guys, let's get started. Do you have any questions? No? Okay. So I sent you the email on Tuesday night, I think it was around night, to check the grade for the exam, so you can pick up your test after class today. Okay? So if you want to see what you did, you can pick it up. All right. So today the plan is to finish the discussion about general functions, okay, which is the content of test number 2. Therefore, the second exam is going to be next week, okay? Instead of doing it on Tuesday, let's do it on Thursday. That way you have some time to prepare, do some homework, some problems, etc. So the exam will be on Thursday, okay? So on Tuesday, we're going to be doing all the stuff, which is for test number 3, okay? We're going to begin unit 3 next week. All right. So let's talk about this. So again, we have talked about what a function is, and then some basic properties like evaluating function, figuring out the domain, the average of change, the difference quotient, and then the notion of symmetry, right? This is what we discussed last time, even odd functions. So now it's time to start talking more about the graph of the function, okay? The graph of the function itself, and in particular, there are some functions that are very basic, and most of the functions that you're going to encounter are going to be some sort of variation of the functions that you will see here, okay? So that's what we call the library of basic functions. There will be about 8 functions. And what I expect you from you is when you see a picture, when you see that picture, you need to have a formula in your mind. And if you see a formula, you need to be able to have the picture in your mind, okay? So it's like a dictionary, formula, picture. You have to be able to recognize both. So you need to learn them, okay? All right, so let me just write this down. So the first one, again, most of these are very basic. Like for example, the function f of x equals b, where b is a real number. So this one, we call it the constant function, okay? So we call this the constant function. And like the name suggests, this function is a constant. So what's the graph of this function? How does the graph of this function looks like? Yes?
It's just a straight line.
Okay, all lines are straight. Yes. I mean, this is a straight line. Well, assume that it's straight. A straight line. So be more specific. What do you mean by straight line? Huh?
I think a vertical line.
Is a vertical line a function? If I do this, is this a function?
That's not. That's
Okay.
not a vertical line. That's a horizontal line.
So it's a horizontal line. See? So again, remember, f of x stands for y, right? So here we're just saying y equals b. So particularly we're saying here, we don't care what x is. X can be whatever you want. The value of this function is always this number. So how will the graph look like? That's just a horizontal line, okay? No matter what x is, y is always the same number. That's how you fix a number. You draw a horizontal line if you want to fix a y number. If you want to fix an x value, you draw a vertical line, okay? So this is just a horizontal line. Let's say b is somewhere in here. I don't know. Let's put it here. Then this is how it looks. Okay. So once again, you see something like this, a picture like this has to be in your mind. You see a picture like this, you have to be able to write this formula. This is the first one. It's called the constant function. So next, so I guess, all right, so let's do this. So for each of these functions, let's write down the domain and range, okay? So let's see, what's the domain? What's the range? I guess let's say everything we can. Domain, range, and maybe symmetry. Let's give myself more space. So let's find domain, range, and symmetry for each of these functions. Cool. All right, so what's the domain of this function? Yes?
All real numbers.
Or real numbers, so negative infinity to positive infinity. What's the range? Yes?
B in brackets.
B, good. So it's just 1 point, so we just write the set B, okay? All right. What's the symmetry? If anything, remember symmetry is even, odd, or neither. What is it? Even. Good. So as a constant function with basic properties. So now let's look at another function. The function f of x equals to x. This is called the identity function. Identity because whatever the input is, that's exactly the output. So you can think of this as being the function that reveals the identity of the input. Whatever that is, okay? Okay, so how does this look like? What's the graph of this? Okay, let me. Okay.
Slanted line. Like this.
So, but which one? There are many lines that look like that.
Just a straight slanted line.
Say that again.
A straight line like this.
Okay. So I'm kind of joking, but every line is straight. So, and there are many lines that we can draw. With the description that you're telling me, I could do this, or I could do this, or I could do this.
Or with a slope of 1.
So which one is it?
Like a line like this with a slope of 1. And
with a slope of 1. Okay, good.
And it crosses the tangent.
Yes, very good. So for example, it goes to the origin and the point 1, 1, 2, 2. Just give me 2 points. Remember, to define, to fix a line, you give me a point on a slope, but easier, just give me 2 points, right? So 0, 0, and let's say 1, 1. So here's 1, here's 1. So we're talking about this line. Okay, so my axis is not good. This is supposed to be a 45 degrees. But anyway, whatever. By just saying that that's 1, 1, that's good enough. So remember, when we're graphing here, really what we're going to be doing is we're going to be sketching the graph, okay? So that's why every time that you draw a picture, you need to provide points so that we know what is it that we're talking about. So if I tell you this is the point 1, 1, and it goes to the point 0, 0, that's it. There's only one line that does this, okay? There's the line y equal x. Even if this is not 45 degrees, which it should be. But then you have to precisely have the same scale here, here, and all that. Okay, anyways, this is your identity function, and then let's go ahead and let's write down its properties. So what's the domain? So real numbers, range, or real numbers, symmetry. Oh, good. Okay, so remember what I'm doing here is formula, graph. You need to know this like a dictionary. You see the graph, you need to be able to write down this formula. You see the formula, you have to be able to produce this graph. Does that make sense? If you don't know the least that I'm going to do here, do little flashcards. Formula on one side, the graph on the other. And then practice. Okay? All right. So let's see. F of x equals x squared. There's not really specific name for this square function, so I'm not gonna write that down. And how does this look like? What's the shape of this? This is a parabola, good. And we kind of saw an example of this last time. The point is, first of all, there's an even function, right? Because of the x squared, so whatever happens on the right is gonna happen on the left. And the bigger x gets, then y grows faster, right? You need to square the number, the value of x to obtain y. So it goes up. So for example, it goes to 0, 0. It's gonna go to 1, 1. And then when x is 2, we are at 4. 2, 3, 4. And so I remember that by symmetry, then we get these points. Okay. That's a picture like this. And then once again, we have our basic properties. Okay, so what's the domain? What's the domain? Negative infinity to positive infinity. Range? 0 to infinity. Here we need to include 0. What's the symmetry? It is an even function. Okay, good. So then the other one is the cubic function. So the cubic function kind of have the same behavior like the x squared on the right. The only difference is that now if you plug in negative stuff, you're gonna get negative y's. Okay? I like here that when you plug in something negative, it becomes positive. So this other half of the parabola, for example, you need to flip it down because when you plug in negative things, you're gonna get negative y's. You understand this? So this is gonna create sort of not really an S, shape like this. Okay? So down x, y. So it goes through 0, 0. It's gonna go through 1, 1, and then it goes to negative 1, negative 1. Call these key points. Okay? And then we have this sort of shape. Okay, something like this. That's a cube. This is 0, 0. All right, and then what are the properties of this? What's the domain? So all real numbers, range, all real numbers, symmetry is an odd function. Good. So that's a cube function. Then the next one is right here, the absolute value. So f of x equals absolute value of x. We're going to revisit this function later on. Remember, absolute value, this is the quantity that no matter what the input is, the output is always positive. Okay? So the way to think about this is if the input is positive, it's just equal to itself. If the input is negative, it's equal to minus whatever the input is. Okay? To make it positive. So that means that this has a special shape. What's the shape of this? What is it? It's a V shape. Why is it a V shape? Because this is a combination of two functions, okay? When x is positive, this is a function y equal x, which is this piece of the line. When x is negative, this is the function y equals negative x. So it's this piece of the line of negative x, okay? You put them together, and then you get your V shape. We're going to address this later when we talk about piecewise functions. This is, I guess, our most basic example of a piecewise function, a function defined by pieces. Okay. All right. So again, it's important to show the points. Okay. That way, it's clear what function we're talking about. When you see this shape and then you see these points, 1, 1, and 1, then it's understood that this is just absolute value. No time 2 times absolute value of x or absolute value of x plus something. Okay, so you need to learn these points to really know what the formula is. All right. So what's the domain for this? All real numbers. The range. 0 to infinity. Symmetry is an even function. Okay. The symmetry, even means symmetry with respect to the y-axis. Okay. That's number 5. Then we have number 6, square root function. All right. So what's the domain of the square root function? What's the domain? From 0 to infinity. So that means that right now, so far all the functions that we have had, the domain has been all real numbers. So the picture has have been covering the entire x-axis. This time, the domain is from 0 to infinity, so we're only going to have picture on this part. Okay? we cannot have anything going on to the left of the y-axis because x has to be 0 or positive. And then in the case of square root, you know, the bigger x is, the bigger is the y, so it's going to be going up. Also, you know, it's positive, so everything is going to happen here in quadrant 1, okay? Because the square root is positive. And it's just that it's going to grow a little bit slower than the, for example, the square function grows like this, very fast. This one grows slower, it grows like this, okay? For example, if you want to go up to 2, you need to go all the way to 4 on the x-axis. If you want to go up to 10 on the y, how long do you need to run on the x-axis? All the way up to 100, okay? And so on. So it's growing, but it takes more time to be able to go up on the y-axis, okay? So that's why the shape is different. That's called, by the way, the concavity. So, for example, this is a concave up figure. What I'm about to write is a concave down figure. Anyways, it goes to 0, 0, 1, 1. And then I guess, let's say, if you want to go up to 2, you need to run all the way up to 4 on the x-axis. And then it has a shape. So you can think of it as being a parabola that is, you know, like this. That's pointing to the, what is it? To the right. A parabola is pointing to the right, but then you are only taking the upper half, okay? Which is actually what happens. Parabola is a general shape. It doesn't have to be pointing up. It could open to the right, to the left, up or down, okay? Anyways, square root is just this half of this particular parabola. Okay. That's a square root function, and then we have all these properties. What's the domain? Domain? 0 to infinity. So I have to put bracket here. Range? 0 to infinity. Symmetry? It's neither. Right? There's no symmetry here. It's not symmetry with respect to the y-axis. There's nothing going on over here, so that's not reflecting. And it's not odd because there's nothing going on down here. Okay? All right. So a square root function. And by the way, the square root, in a sense, is the function that somewhat cancels this function. Okay? I'm saying somewhat because not exactly this one. You need to do a restriction. You need to get rid of this half. So if you restrict this to x greater than or equal than 0, then the square root would be the inverse of this function over here. Okay? All right. So, and the next one would be the cube root. This one is the one that cancels x cubed, right? It's the inverse of the x cubed function. And again, it's a slow growing function, just like the square root. Okay, it's not the slowest, but it's a slow growing function. And to the right here, we're going to have a sort of the same shape. But then the thing is that now the domain is already a number. You can plug in also negative stuff in here, so you need to allow yourself to go on the negative side. And if you plug in negative x, you're going to get negative y's. So the same picture that you have over here is going to translate down here. And because this is an odd function, you can factor out a negative, then you just have to flip it with respect to the origin. So if it goes this way, then this part has to go this way. Okay? You put it together and you get a sort of an S kind of thing. But it's not really an S. But anyways, here is 1, 1, so I have to go through this point, -1. So -1, -1, it has to go through this point as well. And it has this sort of shape. Okay? Any questions? So how long does it take to get up to 2? I mean, this is even flatter than what I draw here, because if 2 is right here, where are we supposed to be on the x-axis to be able to climb up to 2? 8, right? Instead of 4, before we only need to go to 4. Now here we need to go to 8. If you wanted to climb up to 10 on the y-axis, how far along do you need to go on the x-axis? 1,000. Before it was only 100, now it's 1,000. So this function is lower than this one, okay? It's growing, but at a slower rate. Okay, but nevertheless, it's growing. So basic properties. So what's the domain? What is it? All real numbers. You can plug in whatever you want. What's the range? All real numbers. And what's the symmetry? This is an odd function. Okay. All right. And then our last basic function is going to be the reciprocal function. Function 1 over x. We call this the reciprocal function. Because, you know, the job that it does is giving a number, it flips it. Okay? If you plug in 2, it gives you 1/2. If you plug in 1/2, it gives you 2. Okay. So, you know, we haven't talked about this type of functions yet, but we will at some point. Okay? This is, I guess, the simplest example of what we call a rational function. And now this time, let's also, so far our functions have been one piece, right? So if you look at the functions that I've drawn so far, we can do it without lifting the pencil, so to speak. Okay? They're just one piece of the function. By the way, functions like this, we call them continuous. Okay? You're going to study this in calculus, but the formal notion means a continuous function is a function that you could draw without lifting your pencil. Okay? No holes, no gaps, nothing weird happening. So far, all the pictures that we have had have been like that, continuous function. Now, the problem here is that we have an issue. What is the value that we're not allowed to plug in here? 0. So 0 is the number that we need to avoid, but anything else is fine, right? So you can plug in positive stuff, you can also plug in negative stuff, but you cannot plug in 0. So that means this whatever the graph is, it cannot touch the y-axis. You understand this? So this is forced to be divided into 2 pieces. There will be one piece of the graph over here, and there's going to be another piece of the graph over here. All right? So this is an example of a function that's not continuous, because you cannot draw it continuously. Okay? You have to leave your pencil. So let's see how it looks. Let's see. By the way, is this even or odd? This is odd. So that means that we only have to worry about what happens on this side, right? And whatever picture we have over here, we can use symmetry to reflect it. Now, notice that when x is positive, what do you know about y? Is it positive or negative? It's positive, so that means on this side, the picture is going to be here in 1 and 1. You understand this? So whatever we get here, all we have to do then is reflect it down here by symmetry. So let's worry about the shape of the function over here. And we just plot some points. For example, when x is equal to 1, what is y? Y is equal to 1. Okay, good. So we have to go through this point. Now, let's try to think what happens. Let's see. Let me do one more. So when x is 2, what is y? 1/2. So when x is 2, we are already halfway here, between 1 and 0, right? And then the bigger x gets, what's going to happen to the y value? It's going to get smaller and smaller and smaller. Do you understand this? For example, when x is 10, this is 1/10 of this little interval. Okay? And so, I mean, you will never get 0. Do you understand that it will never be equal to 0? A fraction is 0 only when the top is 0. Here the top is 1. Okay? But this can get as small as you want. So that means that as you go to the right of the x-axis, this picture is going to get very, very, very close to the x-axis. Okay? So we have that behavior. We have a name for the x-axis. That's called a horizontal axis. Okay? So we understand what's going to happen there. Now, on the other side of the spectrum, what happens as we go towards the y-axis? So let's say that we get something smaller. For example, let's pick 2, 1/2 as an input. If I plug in 1/2 in here, what do we get for y? 2. We get 2. Remember, this flips the numbers. So we're going to get 2. And then, you know, if I get something very close to 0, for example, let's say 1/100. That's a tiny little number here. What's the y value corresponding to that one? 100, all the way up there. If I get 1/1,000,000, then we're gonna be all the way to 1,000,000 on the y-axis. Do you understand this? So what does that mean? The closer we get to the y-axis, our function is gonna go up to positive infinity. Does that make sense? So this is called the y. We cannot touch it, but you can get as close as you want to the y-axis without touching it. This is called a vertical asymptote. Okay? So that means that the shape is something like this. So we're gonna have, we have to go through all of these points and then get very close to the x-axis and very close to the y-axis without touching. Okay? So we're gonna have this sort of behavior, and then by symmetry, this reflects over to the other side as well. Let me just draw -1, -1, and then we'll have this sort of picture. Okay? So that's the reciprocal function. It's understood that this keeps going like that without touching the x-axis, and this keeps going down, getting closer and closer to the y-axis, but never touching. Okay? Questions? Yes?
How do you know whether or not a function is even odd or even?
So remember, we talked about that last time. So from the formula, what you do is you plug in negative x, right? And then when you plug in negative x, you get back the original function is even. If you get back minus a function, it's odd. So let me show you that here. So this was the condition for even from the formula point of view. So if you plug in negative x and this equals the function itself, then that's even. In other words, if you can get rid of the negative without changing the formula, then it's even. Think about x squared. What happens when I plug in negative x here? The square kills the negative, and then you get back x squared. So that's a classic example of an even. And then odd function means that if you plug in negative x, then somehow you can factor the negative out of the function. That's what it means to be an odd function. So you get back minus f of x. Classical example is y equal x or x cubed. When you put a negative here, then the negative survives the cube, so you can take it out. You get minus x cubed, which is minus a function. And for example, in our case, right now we're talking about the function 1 over x. And if I plug in negative x here, you're going to have 1 over negative x, and then the negative you can put it in front of the fraction. Because as I said last time, you can put the negative wherever you want. In the bottom, the top, or in front. Okay? So that's minus the function. So symmetry, it helps you to quickly graph something. If you don't know what the graph is, you just have to find one piece, and then by symmetry, you get the other one. But the function needs to have symmetry, of course. Okay? All right, so again, we're going to have an entire section just dedicated just to rational functions, so we'll have more time to talk about this time. So I'm not going to be addressing this one too much until we get to rational functions anyways. All right, so basic properties. What's the domain here?
All real numbers except 0.
All real numbers except 0. So that would be negative infinity to 0, union 0 to infinity. What's the range? Same thing. We also need to skip 0, right, on the y, because we never touch the x-axis. So negative infinity to 0, union 0 to infinity. Symmetry? Odd. This is an odd function. And then I guess that this one is special enough because this one is not just a picture that you see. It comes together with two special lines, the horizontal and the vertical asymptote. Okay, we talk about those once in general once we talk about rational functions, but let me write them here. So there is a vertical asymptote. And there is a horizontal asymptote. What's the vertical asymptote? What's the equation? X equals 0. Good. And what's the horizontal asymptote? Y equals 0. So remember, vertical lines have equation x equals some number. What number? Well, whatever is the x value that the line goes through. Horizontal lines have equation y equals a number. What number? Whatever value the line goes through on the y-axis. The x-axis is equation is y equals 0. The y-axis is equation is x equals 0. Okay? All right. Questions about this list? So again, as I said, you need to take this as a dictionary. See the picture, I have to write the formula. See the formula, you need to be able to write the picture. Because now what we're gonna do is, we're gonna start taking these functions, we're gonna start moving these functions around in the plane, okay? So we want to move them up, down, right, left, stretch, compress, flip them, do a bunch of transformations to them. And the idea is to be able to recognize that at the formula level, okay? Like if your formula, you need to recognize, oh, this is coming from this function, let's say, and then what we're doing is we're moving to the right, then up, and then flip, or whatever it is that we're doing, okay?